Hello everyone. So this is a question from NEET 2026. Select the reagents that reduce nitriles to primary amines. Important. Reduce nitriles to primary amines. Okay. So certain these reagents are given to us: lithium aluminum hydride, water. Second is tin plus HCl. Third is hydrogen in the presence of nickel. Fourth is sodium amalgam in ethanol. Fifth is bromine in aqueous NaOH. Okay. The chapters involved is amines. Okay. So nitriles or cyanides are, RC triple bond N. So RC triple bond N, these guys are known as nitriles or cyanides. And primary amines are, you know, um, primary amines or 1 degree amines are basically, NH2 group connected to carbon, which we can represent it, NH2 actually connected to an alkyl group, which we can represent it in this fashion, RNH2. Okay. So these are known as our primary amines. So let's look into the reagents one by one. The first reagent is lithium aluminum hydride, and in the first sequence we have first as lithium aluminum hydride and the second one is water. So whenever we have cyanide or nitrile, that is RC triple bond N, and first it is acted by lithium aluminum hydride, which is usually in dipped in ether, and second reagent is H2O. So whenever these reagents are present, so the nitrile or the cyanide get converted into RCH2 and H2. Okay, so we had we have a nitrile or a cyanide, and we are getting 1 degree amine. So yes, so therefore we can use A to reduce nitriles to primary amines. Okay, therefore A is correct. Then we have B. So in B we have Sn, which is tin, which is an active metal, and it is combining with concentrated hydrochloric acid, that is HCl. Okay, so these two guys are used to convert nitro compounds into primary amines. Very important. So these two are used to convert nitro compounds into 1 degree or primary amines. For example, let's say we have nitroethane, which is CH3CH2 NO2. So this guy, so whenever it is acted upon SnHCl, so Sn, that is tin and HCl, so these are reducing agents. So they will give us nascent hydrogen. So what is nascent hydrogen? Hydrogen that's released in a reaction and it has not combined to form molecule yet. So there will be nascent hydrogen which is released by the reducing agent, and obviously reduction is going to happen and we get CH3, CH2, NH2 and water. So this is our ethyl amine. When we balance this, here we'll have a 6, here we'll have a 2. So therefore we cannot use tin plus HCl as our reagent to reduce nitriles to primary amines. Okay. Then we have C. In C, we are using hydrogen in the presence of nickel. So when we have RC triple bond N, that is nitrile or cyanide, and when it is reacted with hydrogen in the presence of nickel, which is acting as a catalyst, so obviously reduction is going to happen and we get RCH2 and H2. So we have a nitrile or a cyanide and we are getting 1 degree amine. So therefore C is also correct. So we can use C also. Then let's talk about D. So in D, we have sodium amalgam in ethanol. Okay, so whenever we have nitrile or cyanide, that is RC triple bond N, and we are reacting it with NaHg, which is sodium amalgam, and sodium amalgam is an alloy of sodium and mercury. Okay, so this is sodium amalgam, alloy of sodium and mercury, that is Hg. Okay, so this is in ethanol, C2H5OH. So whenever these two guys are present and whenever you have a nitrile or a cyanide, so this gets reduced to the corresponding primary amine. So we will be getting RCH2NH2. So therefore, yes, D is also correct. So we can use sodium amalgam in ethanol to reduce nitrile to primary amines. Then we have E. Bromine in an aqueous solution of sodium hydroxide is used to convert amides into 1-degree amines. Very important. It is Br2 in aqueous solution of sodium hydroxide. So this is used to convert amides into 1-degree amines. So this is the famous Hoffman bromamide degradation reaction. Okay, that is, for example, let's say we have an amide, that is RC double bond O NH2. So when this guy reacts with bromine and NaOH, so we get the corresponding 1-degree amine having one carbon atom less compared to the amide, you can see. And there are other side products like sodium carbonate, NaBr, and H2O. So when you balance this, we'll have a 4 here and 2 here and 2 here, right? So therefore, we cannot use bromine in aqueous NaOH to reduce nitriles to primary amines. So therefore, E is not correct. Okay. So therefore, the reagents that reduce nitriles to 1-degree or primary amines is A, lithium aluminum hydride and water; C, hydrogen in the presence of nickel as catalyst; and D, that is sodium amalgam in ethanol. Okay, so therefore A, C, and D are the correct reagents. Okay, thank you.